Page 485, we're talking about the triangle proportionality theorem. In the previous pages of videos, we talked about how if you have parallel lines, they create similar triangles which have proportions. But we can do the converse of that, which says if you have proportions, and they're truly equal proportions, then you have parallel lines. It's a whole twisteroo. We have that in question 6. Determine whether MN is parallel to PQ. Well, MN is this line, and we want to check if it's parallel to PQ. We'll use proportions to do it. I highlighted 9/4. I highlighted the 9/4 as yellow, and I highlighted the 7.2 and 2.7 as blue. The question is, let's just check if they're equal. Hey Siri, what's 9 divided by 4?
It's 2.25.
Hey Siri, what's 7.2 divided by 2.7?
It's approximately 2.6666.
They're not equal. They have to be equal in proportion for the sides to be parallel. So not equal, not parallel. That's what you do. You check whether or not the two sides are in proportion, the pairs of sides, and then if they are in proportion, then you know that the lines are parallel. Why don't you try MN and PQ for the second part? I guess it says 6A. Again, let's just make that be a B. Now, why don't you try that as well? I'm going to highlight yellow. I'm going to stop talking. I'm just going to get to the answer. So pause, do it, skip forward 30 seconds, and see if your work matches mine. We're trying to determine if there is justification that the sides are parallel. And you're back, and we're back. So what I did is I took the 32/4, maybe you did as well, then I took the 24/3 and I reduced them. And when I reduced them, I got 8 equals 8. And because the two fractions make congruent, equal amounts, yes, the lines are parallel. That is the reverse of the triangle proportionality theorem. The converse is the better logical word. Let's do that for the next 4 questions. It's not your bell, it's mine for when I have time left. Use the diagram and follow the steps to prove the conjecture. If 3 parallel lines are intersecting by 2 transversals, then they divide the transversals proportionally. So we have 1, 2, 3 of them. They're all parallel, and we want to prove that AB over BC equals DE over EF. So that's AB and BC, and it's DE and EF. Use the triangle proportionality theorem. What can you conclude? In fact, it says through any 2 points, there is exactly 1 line. Let's draw an auxiliary line. I don't have my, where's my projector? There we go. Through segment CD to form ACD, FDC. It has to look like this. So draw an auxiliary line right here. Remember, that creates the triangles that we're talking about, which means this angle and this angle are the same. That means, because of alternate interior angles. Okay, what can I conclude here? I can conclude this. AB over BC equals DH. Where's the H at? Get the H out. Label the intersection of CD and L2 right here. That's H. So I can then conclude that DH and HC are equal. Use the triangle proportionality theorem and triangle FDC. What can you conclude? I can conclude DH over HC equals DE over EF. That's where the sections in the triangle. So there's a triangle up here where those 2 segments make proportional amounts. And then there's a triangle over here where those 2 triangles make proportional amounts. So therefore, by the property of equality, these 2 things being DHHC, we have AB, BC, DE, EF. This is called proportional segments theorem. There's a whole video on it. There's a whole poster about it. Thank you for watching this video, and I'll see you in the next episode.